Want to know how a 1 bit of memory is stored in a flip-flop or any kind of memory storage element? So here is the lecture that is for you. So what's this lecture? To know how the 1 bit of information that is processed, changed and analyzed and everything. So last class we have discussed about SR Latch. So there we have a two disadvantage, that is a presence of invalid state and no control input. So now let's get into the flip-flop, how these disadvantages can be taken into control. So here the one main disadvantage of the no control input that can be reduced here with the help of clock pulse. So whenever there is a clock 0 which is given to this, then output will never change. So that will resemble as it is given. So thus disadvantage is overcome here. So how the SR flip-flop build is that with the help of NAND the SR latch that has a NAND circuit inside it. So same thing, and another two NAND gate which is added, the same S and R input with the clock as a output. Okay. So let's see how the output will be changing. So here we already know whenever the 0 0 input that is given here, so clock will be 1 here. So the output available will be 1 1. So if it is 0 and 0 here, then 0 into anything is 0 and the toggle input is 1 1. So whenever the SR flip-flop input is 1 1, then the output change will be the same as it is. So whenever similarly the 0 1, whenever we are giving 0 1 here, so let me take a modification. When we have 0 and 1 here, so 0 into 1 that will be 1 and the same. So here also 0, that is 1 into 1, here that will be changed to 1. So whenever 1 0 is given, then the output will be set to reset. Okay, so that is what the condition. So here we are applying 0 1, but here there are 1 and 1 0 is going. So from the SR latch NAND and truth table, whenever 1 0 is given, output will be reset, so that is 0. So 1 0 is giving, then here will be going to 1 and 0, so then that will be reset to 1. So 1 1 is goes means then here will be 0 and 0. So 0 and 0 will be considered as invalid state. Instead of invalid state, we are considering that as a X. So that is what the thing, the two different changes, that we have a clock thing and we are considering this as a X state. So here this is how we can eliminate it. So even this can be changed to NOR. With the help of NOR also we can build the logic. But the quite difference that what we have to do is that the same, but instead of NAND gate we will be changing that into AND gate. So that is what the change that we have to do. So let me draw the thing so that you guys can able to understand it clearly. So this is the SR latch. So the same SR latch, but inside with is a NOR gate. Okay. So let me draw the AND gate. So instead of NAND gate, here the input will be taken and given to AND gate. So because now the truth table need to be same for both, even if you are using NAND or not, the output need to be same, because that is making some confusion, right? So if we are using OR, we use OR, then that will confuse. So in order to avoid that, so we are coming up with the same thing. So how we can reduce that? So let's see. Okay. So here this input can be directly given to this one. So this one also can be directly given to here. Now this will be adjusted to clock. Okay, so now it will, the truth table output will be same as like this. So this will be clock. So here 1 into anything, that is will be S, always it will be S and always it will be R. So now here if you see what are the input that were given to R and S, that is toggled here. But here there is no NAND, so that will be went as it is. So the table, the truth table output will be exactly same like this one. So this one here, this is a Q bar, right? So similar to that, the both the case, the output, the truth table, everything will be same. So this is SR latch with the help of NOR gate. Okay, so here also we will get the same, and here also we get the same. Okay, so that is quite the confusion between NOR and NAND gate can be avoided here. So that is one thing. Okay, so now let me develop the characteristic equation to characteristic equation. So characteristic equation is the equation where the truth table can be written as single thing. So like similarly how we are getting the function for thing. So here let us develop a characteristic equation. So SR Qn and Qn plus 1. Okay. So just we are using the truth table, right? So instead of truth table, we will going to find one equation like how we are done in K-map, right? So similar to that, we'll be using K-map and we'll be doing. So here we are getting the state. So whenever we are mapping into 2 2. So 0 1 0 1 1 0 1 0 1 1 1 1. Okay. So whenever there is a 0 and 0, the output will be same. So if 0 is there, then next state will also be 0. 1 is there, next state will also be 1. So here in the both the thing, the output will be no changes. So in this case, the output will be 0, whatever may be. So even if it is 0 or 1, output will be 0. So here output will be 1. So even whatever the condition, even it is 1 or 0, then the output will be what? 1. So here also whatever the state, the output will be x because that is an invalid state, right? So let me draw a what that K-map. So you guys can also pause the video and try the K-map because we have already discussed the K-maps, right? So please revise the concepts. It will be helpful you guys to have the core knowledge all the time. So please never forget it, revise it until you get into that your main memory. Okay. So here let me take S here, R and Q in here. Okay. So whenever the output is 1, so let me mark there. So it's 0, 1, 0, 0, 0, 1, 1, 1, 1, 0, right? So here it is 1, then 1, 1, here it is x and x. Okay, so whenever 1 and 1 is x. So how we can map the thing is that here let me map these 4 elements and these 2 elements. Okay. So if we draw a truth table, draw a equation characteristic for this. So Qn plus 1 which will be equal to, this one is S plus, so this one is R bar Qn. Okay, so this is one of the very important equation, guys. So SR flip-flops characteristic equation is this one. So if you substitute this value, for an example, let me take this one. So if S is equal to 0 and R is equal to 1 and Qn which is equal to 0. So if we substitute all here, so 0 plus 0 into 0, the output will be 0. So we have got this, right? So we have applied this and we have got this. So let me substitute this one. So whenever S is equal to 1 0 0, so S is equal to 1, so 1 plus anything, the output is 1. Okay, so we have get this simple thing. So instead of memorizing or remembering all the thing, so with the single equation we could get any value. So this is one of the important things. So this is what the characteristic equation of the things. Okay, so there is another one thing, that is excitation table. So these are also new terms that we will be studying for each flip-flops. So please try to make how you can simply remember those things, or you can even derive it, but this will take time. Simple. So here there will be SR, then we write in both things. So here Qn plus 1, based on that we will be write R. Okay, so that is what the great difference. So 0 0, so 0 1 1 0 1 1. The thing is that when output is changing from 0 to 0, what will be the possibility for these values? So that is one thing. So output is changing to 0 to 0. So here you see output is here also changing to 0 to 0, 0 to 0. So this is the two condition. In this two condition, if you see, S is same. So S is always 0. Here R is 0, R is 1. So here the R can be anything. So like this way we will be mentioning, that is 0x. So let's see when the output is changing to 0 and 1. So if it is changing to 0 to 1, so where it is changing, so here it is changing to 0 to 1. The condition is 1 0. So it is directly you can return. So 1 0. When the condition is changing to 1 to 0, here if you see 1 to 0 is changing at here. So that is 0 1. Okay. So when the output is changing to 1 to 1, so here is 1. Okay. So if that is a condition, then that is a reverse, x is equal to 0. How you can remember the thing is that you remember this one. So 0 1 0x and reverse it. So x 0 1 and 0. Okay. So this is how you can remember the excitation table simply. So but I am suggesting you guys to this will be a shortcut, but know how this is came. So then only you guys won't be confused. Okay. So I hope three things we mainly mean to focus, that is characteristic equation, excitation table, and the diagram, and or the truth table. So anything is fine. So these three things is very important, guys. So I'm sure that this is giving you a very good understanding on these things. So I am suggesting you guys to like, share and subscribe the channel, and you get more information and informative videos like this. So I'm helping you. I'm thinking this is helping you guys. So please watch these videos and continue your learning and be more curious to learn different things. Then only we can be top at our core things. Thank you guys. Stay tuned.